Hello, so in this video we're going to look through this idea of hypothesis testing. Now I know there's a lot of videos out there and there's a lot of resources out there on hypothesis testing, but what I'm really going to focus on is the motivating idea, the underlying idea behind what is a hypothesis test. Okay, the reason why that is important, rather than just treating it as an algorithm or a process that we just kind of have to follow, the reason why I really want to understand what is it going on behind hypothesis testing is, number one, I think it makes you feel more confident if you can actually get to grips with the sort of behind the scenes action, if you like. But also, it's really important to understand what a hypothesis test is actually doing in order to interpret results objectively, okay? So the first thing that I'm going to do before I just sort of jump in with hypothesis testing is I'm going to try and relate it back to something that we've already done. Namely, I'm going to look at it from the perspective of confidence intervals. Now, if you haven't watched my video on confidence intervals, I would recommend that you go and do that because it will help here, okay? Will help you give more of an understanding here. But if you haven't, the basic idea of a confidence interval is you look at some sample data and you collect a sample mean, okay? So you collect a sample mean from data, and then you say, well, okay, given some particular sort of sample size and also a known standard deviation, you can say within some level of confidence, and we call that the confidence level, okay? So for example, we might say that the confidence level is, I don't know, 95%, okay? So 95% confidence level, right? We can say within some level of confidence that the true population mean should lie within some given interval. Okay, and the interval is determined by the sample mean and also the variance and the sample size and also the confidence level. So you can, in other words, you can say that the true population mean is going to lie within this interval somewhere. And we talked about how we can construct this. Now, hypothesis testing kind of does the same thing, but it looks at it from a different perspective. So with confidence intervals, the kind of main character, if you like, is this thing called the sample mean. Okay, so we were looking at it from the perspective of the sample mean. That was the main character of our confidence intervals. Okay, now with hypothesis testing, the leading character, the main character, is actually a believed population mean. Okay. So in other words, you believe that the population mean is equal to this, you then go away and you say, well, okay, I collect some data. Now what's the probability that the true population mean is actually equal to some value, okay? And because we're dealing with probability, we deal with it from the perspective of something called a significance level. Now, just to give you a bit of background, okay, now like I say, if you haven't looked at this confidence interval video, I strongly recommend that you do, okay? But let's suppose that our confidence level is 95%. Now, these two things, the significance level and confidence level, are related in that they are complements of each other. So confidence level with 95% would mean that significance level would be 5%. Now, if you think about it, when we're doing our confidence intervals, we thought about this literally just by drawing ourselves a normal curve. Okay, so we drew ourselves out a normal curve, and then we said, well, okay, there's going to be some value in the middle, okay, and that was actually our sample mean, and we wanted to include 95% of our data. So in other words, we looked at a region which was centered around our sample mean, which contains 95% of our data. So that region in there would be 95%, okay? Now, if we look at it from the perspective of a significance level now, because they are complements, all it means is that we will be looking at the other region on the graph. In other words, the extreme regions or the tails of the graph, if you like. So if our significance level is 5%, well then I'm splitting my 5% in this case equally amongst two intervals, amongst two regions. So therefore each region is going to be 2.5% each. Okay. So in other words, hypothesis testing and confidence intervals look at pretty much the same thing. We're trying to establish what is our true population mean. So what is this? This is the core idea of confidence intervals and also hypothesis testing. What is the true population mean? Confidence intervals does it from the perspective of the sample mean. and then it says, well, okay, I want to include 95% of my data, so therefore my true population mean is going to lie within some particular range. From the perspective of hypothesis testing, I actually come up with a believed sort of value of my population mean. And then I go away and I try and come up with a probability to say, well, actually, how likely is it that that true population mean is actually equal to that value? Okay, but you notice that they are related in that way. So don't think about these two things separately, think about them together. Okay, so here is the core idea. Okay, actually I'm going to start with a motivational example. So let's suppose I have some sweets. Okay, and these sweets, if I look on the back of these sweets, they have a weight, or they have a stated weight on the back of the sweets of 100 grams. Okay, so this here is, if you like, my believed population mean. Because it's stated by the manufacturer, okay, I can assume that the true population mean should be equal to 100 grams, okay? Because that basically means if I go out and if I collect every single chocolate bar of this type which has ever been made, take the mean of all of those chocolate bars, it should come back as 100 grams. That's what I currently believe to be true. That's my population mean, okay? Now, this is my currently believed value, okay? So I give this name a null hypothesis. So if you think about it, a hypothesis is just simply a claim which I believe to be true, okay? It's a claim which either I want to test or something which I want to be true, okay? So this, if you like, is my null hypothesis. Now I give it some notation. So the notation which I give it is H for hypothesis with a little 0. So null hypothesis, it's the sign of currently accepted value. It's the null hypothesis, so it's H naught, okay? Now, I always test this against another hypothesis, okay? So this is what I currently believe to be true. I always test it against what's known as an alternative hypothesis, okay? So this is an alternative hypothesis. Right? So notice the notation for alternative hypothesis. It's a little H1 that follows on for H0 for the null hypothesis. Sometimes you'll see the alternative hypothesis written as HA. Okay, so a little subscript A, just for alternative. Okay, so just be aware of the two different notations. Now there's three different types of alternative hypothesis. So in this case, we look at hypothesis testing to do with the mean. Just be aware there are other types of hypothesis testing. So you can do a hypothesis test, for example, for proportions, or for sample sizes, or you can even do it for variance as well. But in this course, we only look at it from the perspective of trying to establish what the mean is. Okay, so there's three different types of alternative hypothesis. Number one, you can either have that mu is greater than 100 grams. So if you currently accept that the null hypothesis is 100 grams, you could have that the actual mean weight is bigger than 100 grams. Okay, so this is the sort of true mean weight. You believe that that is true, so it's currently 100 grams, but it could be greater than 100 grams. That's one option, okay? The other option which you could have, is that the true mean weight is actually less than 100 grams. Okay? And of course, the third option is kind of a combination of both these two. So it could be both greater than or less than. You don't care whether it's greater than or less than, you just care it's not 100 grams. In which case, you could say it could be not equal to 100 grams. Okay? So these are your three options for the mean. It can either be greater than, it can be less than, or it could be not equal to. Okay, now just remember, when you're looking at hypothesis testing, you're looking at the probability that a value will lie in these extremes, so the tails, if you like. Okay, so for greater than, if I just make a quick sketch of my curve, in fact, I'm going to make 3 sketches, okay, to make it consistent. So if I'm looking for a value which is greater than 100 grams, I'm basically saying, at the moment, my true population, or my currently accepted population of 100 grams, my currently accepted population weight of 100 grams, is going to lie in the middle. Okay, so it's going to lie in the middle of these curves. I'm basically asking, well, what is the probability that I go out and collect a sample and it ends up, if it's greater than 100 grams, what's the probability that my sample will end up over here? Okay, in other words, on the right tail. In fact, I call this a right-tailed test. Okay. If I'm looking at this, so what's the probability? So what's the chances of my true mean weight lying less than 100 grams? In other words, to the left, is going to be called I'm going to looking over here, so it's going to be called a left-tailed test. So I'm looking, what is the probability that a value will end up in this left tail? Then finally, you can think about this last one, as being both greater than 100 grams or less than 100 grams. In other words, both. I don't care whether it's greater than or less than, I just compare that it's not equal to 100 grams, okay? In which case, I'm going to be looking at both less than and also greater than, okay? In which case, this is going to be a right-tailed test. So these are the three types of tests which you can do in hypothesis testing. You can either have the alternative hypothesis is greater than, in which case you need to look at a right-tailed test. In other words, what's the probability that a value ends up in this tail? You can either look at the alternative hypothesis being that the true mean weight is actually less than 100 grams, in which case you're looking at the probability that a value ends up over here in the left tail. Or you can say, well, what's the probability that the true population mean weight is not 100 grams? In other words, it's over here or over here, in which case it's a two-tailed test. Sorry, I got that wrong. It's going to be a two-tailed test. Okay, it's not a right-tailed, it's going to be a two-tailed test because there's two tails here and here. Okay, so it's going to be a right and a left-tailed, so it's a two-tailed. So this is the basic idea behind a hypothesis test. These are the types of tests which you can do. What are a hypothesis? What's the link between hypothesis testing and confidence intervals?